Goes up to 95%, right? I don't care when you learn it, that I care. Say this every time. I don't care when you learn it, I care that you learn it. I heard someone say it, right? I don't care when, I care that. So improve your understanding, ask the questions you need to, and let's engage in this conversation. So simplify each expression using I. Now first off, what is I? We got to make sure we understand this because I have a question on this on every unit test. By the way, does everyone have a marker, a colored pencil, a pen, something to make notes with? Alright, everybody's got that? Okay, so I have a question about this on every test, every single time, where I ask, what is the number I and why is it important? And students miss this every time. We don't want to miss this. What is the number I? Square root of? You know what students tell me every time I is? Without fail. They tell me I is -1. Remember, and so Leah, you were asking about this earlier, right? Can I be under the radical? Technically, depending on the way that it's set up, the answer is yes, but with us, it's never going to be the case, right? Because I is the square root of -1. And why is it important that I is the square root of -1? I do want to go ahead and remind us and establish this. What does that allow us to do? So remember, before we had the number I, if I squared any number we had, what did it always give me? Not this kind of number, it gave us a positive, right? If I take 4 and I square it, what do I get? 16. If I take -4 and I square it, what do I get? 16. But what do I get if I do 4i squared? -16, right? So the imaginary number system allowed us to get to square and get those negatives. So keep that in mind. Square root of -100. What do we do to simplify radicals? What do we want to do? Split into factors, right? Which factors would I want to use, right? So Mary, you were talking about like, oh, the calculator does it for me. We don't want the calculator to do it for us. We want to know and understand this. What factors would I want to use with -100? Say it one more time. So you could do 5 and 20, but first off, are 5 and 20 going to give me a -100? Times what? Okay. Now, I'm going to show this, and I want you to think about this. While this is completely legal, because that would give me these square roots, is that going to help me a whole lot? Do we know what the square root of 5 is? No, it's going to be what kind of, well there is, but it's going to be what kind of number? Not just a decimal, it's an irrational decimal, right? That decimal is going to continue forever, it's not going to repeat, and it's not going to terminate. So that's not going to help me a whole lot. Does anyone know a couple other factors that would have been really good here?
25, 40.
Okay, that can work. Say it like that. So square root of 25 times the square root of 4 times the square root of -1. By the way, you don't have to have done it this way. I'll show an alternate path in a second. What's square root of 25? 5. Square root of 4?
2.
Square root of -1? Or 10i. Did anybody split it up a different way?
I do -1.
Couldn't I just do 100 and -1? So, square root of 100 times the square root of -1. Hey Davian, what's the square root of 100? 10. By the way, can you use the calculator to take the square root of 100? 100%, right? But the I will not always work. If your calculator did work, I'm going to fix that before. I'm going to change the settings so that it doesn't work, but notice it gives me to the same spot. So is it okay that Davian did 25, 4, and -1? As long as we do perfect squares, we're good, but again, 100 is a perfect square, so don't make your life harder than it has to be. Does that make sense? What questions do we have about that simplifying process? So remember, split into those factors that you can take the square root of. That's the whole idea there. Factors that you can take the square root of. Should equal.
So like we're not trying to get to like the least are we trying to use the least factor?
No, we're trying to get to perfect squares. Because perfect squares are what I can take the square root of. Right? So like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So I want to see those perfect squares. I want to find perfect square factors because those are the things I can take the square root of. Square root of 16 is 4, square root of 9 is 3, square root of 4 is 2. So I want a perfect square factor. So make a note of that for sure if you didn't realize that. We want factors that are perfect squares. Yes, Landon?
10 on the edge.
Yeah. Why? What were you thinking of, dude?
I don't even know.
Do you understand why we did 100 and negative 1? You take the square root of what you can. Square root of 10 is, or square root of 100 is 10. Like once I take the square root, I'm good. I can do the square root of 25 and square root of 4 as well. 10i is the square root of negative 100. Like if you pick up a calculator and you type the square root of negative 100 equals 10i, you know what it's going to tell you? True. That's a true statement. Those things are equal to each other. So keep that in mind, you can check yourself that way. Alright, gotta move quicker on negative 75. What are the factors I would want for negative 75? 25, 3. Now remember, you take the square root of what you can. Can I take the square root of 25? Is that a perfect square? So what do I get?
5.
Can I take the square root of 3? Is that a perfect square?
No.
So I leave it as square root of 3. Square root of negative 1 is
5.
done. You take the square root of what you can. That's the answer. It's exciting stuff. Questions, comments, concerns?
Could I do 5i first?
5i root 3. Yes, you can do 5i root 3. Like, if you change the order of 2 times 4 times 3, is that the same thing as 2 times 3 times 4? So it's just changing the order. It's called a commutative property. However, we traditionally put the number I at the end. So if you look at the format in the textbook, A plus BI, the real plus the imaginary, and the I always goes to the end. Just be careful because I think, I was talking about with Leah, she was asking that question, that I underneath the radical. The I is the square root of negative 1, don't put your I underneath the radical, but the I typically goes to the end there. But yes, you can switch the order. Okay. Other questions on this one? Remember, just update your knowledge. So which of these following functions would have imaginary zeros or roots? F of x, g of x, or h of x? Okay, why is it f of x?
It's on the graph, it doesn't touch the x-axis.
So remember, my x-intercepts are going to be what type of roots? Real roots, right? We want to remember, if it intersects the x-axis, it's real roots, no x-intercepts, but how many roots does every quadratic have? So no x-intercepts, so the 2 roots have to be what? Here we go. So I was talking with someone after class yesterday who was like, Mr. Kinney, I just struggle with the evidence and explaining why, but like, if you can pick A, there has to be a reason that you pick A. Just put that reason. What do you know? Well, it doesn't intersect the x-axis. That's why I know there's imaginary roots. Okay? With g of x, how do I know there's real roots? Or what could I identify to show that there's real roots? Does anyone know what the roots are for g of x?
-4.
Oh, I just realized that graph is wrong. Yeah, that graph for g of x is wrong. What's the other root though? 0. The reason why I realized g of x is wrong, and I need to fix that for the future, is if I factor out my greatest common factor, I'm left with x minus 4. What's that root supposed to be? Positive 4, and what does that show? Negative 4, yeah, that's my bad. I'll fix that. But we still see 2 real roots, don't we? Regardless, okay? What are the roots for h of x?
4.
4?
And 4.
And 4. Do notice, and I like that, right? It's just that that root is the same. What do we call that then?
Double root.
A double root, right? So that would be that double root of 4. X equals 4. But the priority, again, that b and c is just the extra. The priority is A, there's no x-intercept, so the roots have to be imaginary. Comments, questions, concerns? Can't believe I have that error on here. I'm disappointed in myself. Good? Yeah. Number 4. So one thing I would point out on number 4 is this. What is every number going to fall into? So like I could have easily just made a note really quickly of all numbers are complex. And then you could write out the word complex, or does anyone remember the symbol that we use for that? C. So you could have written out C or written out complex. I'm good with either. So we all get on why this complex. Notice that's a little bit of evidence for why it's complex, justifying it. All right. So Davis, tell me about A. What other number sets would A fall under?
Imaginary?
Is that true? Do we think imaginary? Okay. What letter do we use for that? I. So you could have used I for imaginary or written it out. All right, Hope. What other numbers does A fall under? Not sure? Kyron, do you know? Elizabeth? Are there any others? No, that's it. Cool. If it's an imaginary number, it's imaginary and complex. That's it. So remember, the imaginary numbers have their own branch. Imaginary is the last one on that branch. That's it. And so you can make a note, hey, imaginary numbers, that's the last set that they fall into. Nothing else. All right, what about B? Let's see, Bella, what's another number set that B falls into? Real numbers, do we agree? Okay, why is it real? Okay, but how do we know it's a real number? There's no I, right? All right, notice that's a really quick little note. It's a real number, there's no I. Peyton, any other numbers that one falls into?
I don't know. I put rational, but I don't know if it's right.
What do y'all think about rational? What letter, by the way, could I put for rational?
Is it R? Oh,
So remember, we already had R for real, right? Q stood for quotient.
I thought it was double R.
Say again.
R minus.
So remember, R minus Q is if I have all the reals and I take out the rationals. And if I take out all the rationals, what am I left with?
Is it an integer?
Is it an integer? That's a good question. Why would this be an integer? Say again. I hear two people really quietly talking. Say it loudly.
It's a negative number.
Oh, it's a negative number. Not all negative numbers are integers, though.
It's an opposite.
What is it?
It's an opposite of 9.
It's the opposite of what?
9.
9. So notice we have to simplify it. Isn't negative 18 divided by 2 a negative 9? So not only is it a ratio of integers, it also simplifies to negative 9, which is the opposite of a whole number, and the opposites of the whole numbers are integers. Z, integers, right? Is it a whole or a natural number?
No.
What would it have to be a whole or natural? Well, so notice it simplifies to this, so it could be that. It has to be positive. Remember, the whole numbers are 0, 1, 2, 3, 4, etc. The natural numbers are where you naturally start counting 1, 2, 3, 4, 5, etc. So integer is the last option there. Notice that follows that train or the branch that we looked at there. This is the last one, right? So opposite of whole number. It literally starts out as a ratio of integers, right? Just some of this would have been good for evidence of understanding, but this is complete evidence of understanding. Okay? C, square root of 19. Give me another number set that it falls into. Complex, we already got that one. Irrational, which you can write out irrational or real minus the rational, real without the rationals. Is there anything else?
So, I got a question.
Go for it, Peyton.
So, I tried to put it in the calculator and it gave me like a decimal, so,
Not just a decimal, a hideous decimal.
yeah.
A decimal that did not terminate and did not repeat, correct?
Yeah,
Like, there's a certain point where it has to end because the calculator can only report it to a certain point. But if it's a square root and it's not a perfect square, it's going to be irrational.
okay.
So if it's a square root and it's not a perfect square, it's going to be irrational. That's how all irrational numbers work. Or that's how all square roots work, all roots that are not perfect squares, perfect cubes, etc. Are there any other number sets? I heard someone say integer. Does this fall into the integers? Why not integer? We'll talk about real in a second. Why not integers? So remember, integers are positive or negative. So remember, integers are the whole numbers and all of their opposites. So why is this not an integer? Okay, let me show you this. It's irrational, right? It's the real without the rational. But isn't an integer a type of rational? So to be an integer, it has to be a what first? A rational number. Is this a rational number? No. So could it be an integer?
No.
Remember, the integers also do not have decimals, or don't show a decimal. The integers are the whole numbers, 0, 1, 2, 3, 4, etc., and their opposites. It does have that 19, but where's that 19 located? Under the radical. So, you get with that, Landon? Why it's not an integer? And then yes, is it real? There is no I. Alright, what questions do y'all have about this one? Say again. Girl, you're not supposed to have a pencil out. You're supposed to be making notes on how to improve your understanding. Clear the pencils off your desk. Make notes of how to improve your understanding. Okay. We all good on those? Questions about those previous ones? If you don't ask a question, I can't help.
I didn't even pack this.
Alright, I will point this out, and I need y'all to note this, because I saw a couple of us doing something on 5 and on 6. Guys, there's only one of these that we could use the area model on. Does anyone know which one it is? Why is it on 6 and not on 5? So remember that area model is to help me multiply or distribute. What are we doing on 5? We're subtracting. Be careful about that. Note that to yourself. We are subtracting here. So this is the same as 9i plus 3 minus 4i plus 1. Where did I get that from?
Oh, wait.
I
did. How do you change the, wait.
I didn't just drop parentheses.
The minus to a plus sign.
Yeah. Say again. I distributed my minus. I'm subtracting, think about it this way, I'm subtracting 4i, right? And then I'm subtracting a negative 1. What happens when I have two negatives like that?
I believe I got that right.
So Peyton, think about it this way.
Okay.
Minus 4i, you good with minus 4i? But then it's a minus negative 1. So you have to distribute that negative inside. And when you subtract a negative, what happens?
It's a positive. Okay.
You end up adding. Does that help explain that? Okay. So what am I going to end up with now?
5.
Or typically we write it as, if you wrote 5i plus 4, that's clear evidence of understanding, but be aware, we always write real then imaginary. We do always write real and then imaginary. A plus bi. Because that's how we've defined it mathematically. The best way I can explain it is this. The imaginary numbers were not known or understood at first. So we start with the numbers that we knew, the real numbers, and then we add the imaginary numbers to it. You can also think about it, let's remember this because we're actually going to talk about this in a second. isn't this a whole lot like 4 comma 5 when I am graphing those numbers? So we put our x, or the real first, and then we put our y, or the imaginary second. Does that make sense? But if you look in the book, they always write your complex numbers as a plus bi. Good with that? Is that explained? Okay. Questions about 5?
I was somewhere close.
Okay. Is that evidence of understanding?
Yes. Yeah.
Okay, so remember guys, you don't, with the way that I score and grade, like you don't have to have it perfect. I need to see evidence of understanding. So show me what you understand, we learn from it, we do better next time, right? Miles, is that a pencil on your desk? I know you haven't been using it, but clear that off your desk. All right, number 6. At the core, what do we have to do in number 6? Say it again. Distribute. So you can just distribute as is, but what's the thing that I recommend to help you distribute? The area model. Where's that 1 plus 2i going to go? Does it have to go at the top? It could also be on the side over here. Remember, it doesn't matter the order. 3 times 1 is 3. 3 times 2i is 6i. Notice it's just helping me distribute my 3. Now distributing my negative 2i gives me negative 2i. What's going to go right here? Good. Make sure you remember that's I squared. And I want to point this out. Anyone know how we're going to rewrite negative 4i squared? What's I squared again? Negative 1. So it's going to become what? So plus 4. So you can rewrite it separately in a second, or we want to remember that I squared is negative 1, so really this is going to be a plus 4.
Right. Oh, wait, no. Okay.
Right? So remember, I squared is negative 1, so we're going to rewrite that as plus 4. What are your questions up to this point? Silence tells me we're okay with this information. Ready to improve next time. Alright, so what's going to be my final answer for what 1 plus 2i times 3 minus 2i is?
3.
Are there any like terms for that 3? 3 and 4. What's 3 plus 4? 7. 6i minus 2i is? Right, so we got like terms here, like terms there. That's the answer that we would have wanted. So remember, use that area model to help you distribute. Now I will say, you don't have to, but it is really powerful and really helpful long term. Hope, what's your question?
I have a question.
You sure? Your face says differently.
I know what I did wrong.
Okay, that's fine. Remember, if you know what you did wrong, you can fix it next time, right?
Yes.
I don't care when you learn it, I care that you learn it. Learn from that mistake. Alright. Questions before we continue? Going once, going twice. Sold. Alright. First things first, I told you this beforehand. Please label those axes. Now, technically, x-axis is already good to go. What numbers go on the x-axis? What are those numbers?
Real numbers.
The real numbers, there we go. Okay? What goes on the y-axis?
Negative numbers.
Not negatives. So 1i, or just I,
Oh.
then
So the row going down, that'll be just regular negative numbers?
so not regular negative numbers, negative,
Oh, those imaginary too?
uh-huh.
Oh.
The y-axis is your imaginary numbers.
Oh,
That's it.
so this.
So, 5 minus 3i would be here.
What?
I got that one.
I was
Okay.
right.
Why would you
Negative
do
2
that?
plus 4i would be here.
I'm mad too.
Alright, do I need to explain any of those three?
Can you
Can you
explain
explain
the?
that one?
This
Yes.
one? It was squared to negative
Alright.
1.
Alright.
So this would just be negative 8 minus 3
I'm
I.
just saying, you gotta shake your head, I didn't understand.
This is equivalent to negative 8 minus 3i. So I went to the left 8 and down 3.
Okay,
Oh,
I had
okay.
that point, I just didn't know.
Notice, by the way, would this be quick evidence of understanding why it would go here?
Yes.
Yeah? Similarly, I could rewrite this as negative 2 plus 4i to show why it goes there. You can make a quick note of the real is my x-axis, the y is my imaginary. Drawing out the axes would be evidence of understanding, things to think about there.
Okay, I remember that.
What are your questions to improve understanding? That's really cute, Landon.
Is there such thing as a math movie?
Is there such a thing as a what?
A math movie?
Yeah.
Can we watch it?
No. One of the greatest math movies of all time is A Beautiful Mind that has Russell Crowe playing. Well, I don't want to give away the story, but
You actually watched
You
the
can
math
give it
movie
away.
before.
We ain't gonna
We ain't gonna watch it.
You can give it.
like, let me say this: when I say it's a math movie, it is about a mathematician, a guy with a PhD who broke a lot of codes during World War II, I think it was. Contributed a lot to the mathematical field, but like, it's a really gripping story of humanity. It just is about a
Let's
mathematician.
watch it on the last day of class and here.
I'll consider it.
No, you don't.
I'm
Huh?
not.
You
You right.
Maybe,
I saw it.
maybe.
Are you thinking about that something?
So, number 8, really quickly, roots, also called zeros. Please notice, is that equation equal to 0 yet? No, but if I want zeros, set it equal to 0. Now, you choose which method you want to go about this, but what are the options for solving this equation? Quadratic formula, vertex form with inverses, and distributing is what you would have to do if you already had the factored form, but we could factor. Now granted, could I actually factor this one?
No.
No, if you do 2 times 5, you get 10, a times c, right? Are there any factors of 10 that add up to negative 6? No, which should make sense because probably those roots are going to be imaginary, so you can't factor it right away if it's imaginary. Who used quadratic formula? Show of hands. Who converted to vertex form? Okay, so you can convert to vertex form. I will say if you're doing the vertex here, notice we get a fraction. A lot of us have already successfully done that with fractions, but personally, or for your sake, I understand a lot of us going to quadratic formula. That's what I'm going to use. Setting up the quadratic formula, we should have had. Now, also remember you could write out the quadratic formula for evidence of understanding, but we should have gotten this. Did we get negative 64 here? No.
Huh? Wait.
Square root of, oh, that's 40. Yep, thank you. So negative, wait, no, not negative 8, negative 4, right?
Yeah, negative 4.
Negative 4. So make sure you check that in the calculator. By the way, I do want you all to notice at this point right here, how would you know that it's going to be imaginary roots? The square root of a negative 4, right? So be careful, make sure you type this into the calculator. If you don't know how to do it off the top of your head, which even I made a mistake just then, trying to do it in my head. But just type that radicand into the calculator. By the way, does anyone remember what another name for that radicand here is? Starts with a D. Discriminant, right? We can also call it discriminant. That discriminant's only a thing for the quadratic formula. It doesn't always work. Or it's not always called that. But we see imaginary roots. could technically stop here, but everything also has a factor of 2, so I would have gone all the way to here. The beauty of that vertex form is you wouldn't have to simplify once you get to this point. I may have also written it as 3/2 plus or minus I divided by 2 or 1/2 I, stuff like that. What's your question, Miles?
So I divided the whole thing by 4.
Yeah.
Which says 6 plus or minus 6 squared and
Yeah.
negative 4.
Is that what you got? Where did you get decimals?
I got 3 over 2 plus or minus the square root of negative 4.
So this thing.
Pretty much.
Just remember what you would really be doing here is it would be 6 divided by 4 plus or minus 2I divided by 4, which is how I got that. So you distribute that division by 4. Any other questions about this one? How I got that 2I? Things like that. So there's only one way to do it. You don't have to do it that way. It's your choice. I like choice. I assume y'all like choice. I was like, I don't like choice in math, just tell me what to do. It's not math. That is unfortunately a way that we teach math, but real math is not like that. All right, number 9, y'all ready? Or do we have questions about number 8? Going once, going twice.
You don't have to explain it, but can you like write out the vertex, how to the vertex form for that one?
For this one right here?
Yeah, you don't have to like explain it, just write it.
Sure, really quickly.
Mr. Petey,
Yes, ma'am.
when you're done, can you come look at my paper and see what I did wrong?
Sure.
This is terrible.
What does that give me? 9 halves minus 9.
Let me see. You had more than me, I know that for a fact. That's so wrong. Oh, how you get 16? The calculator told me.
So I'm just writing out the equivalent equations, Elizabeth, not the inverses each time. Now we'll show it here.
4.
I'm good now.
Okay. You see where you made your mistake?
Yeah, I don't see what
So, same thing.
Oh my God.
Okay. Number 9, this is, so what's the first thing I need to do in number 9? Just, I need to make sure it equals, so what am I going to do to make sure it equals 0? I don't move jack in math. It's not how that works. Not distributing anything. What is the language Chrislyn just used? She said we need to make it equal to 0. So what do I need to do to 3x to make it 0? Subtract 3x. And then that property of equality, whatever I do to one side of the equation, I do it to the other. What do I need to do to -5? And listen, I know some of our teachers said move stuff, and it drives me bonkers when teachers use bad math. They do. 11x minus 3x is 8x. 38 plus 5 is 43. Now, quadratic formula or complete or vertex form? Can you use quadratic formula? Sure, it's fine. I would point out that the opposite of b divided by 2a is a nice number. Yeah, that's fine. So k is 27 for those of us who did that route. Is that right? Yes. So 0 equals x squared. Nope. Equals x plus 4 squared plus 27. Just use your inverses. So one really quick note I do want to make here, because I was talking to someone who's in pre-cal right now, who had me in the spring for regular algebra 2. One, it is tough to go from regular algebra 2 up to pre-cal, so I understand a little bit. But another thing is she forgot that I mentioned this. when you convert to vertex form, what that really is doing is a method called completing the square without the difficulty of completing the square. Because notice how I got a binomial squared? So if you ever hear a math teacher in the future talk about completing the square, that's the same as just converting to vertex form. There's just, to me, this is a little bit more straightforward. But vertex form, complete the square. And Miles, you had Miss Williams, right? Just kidding. You had Miss Williams. Y'all talked about completing the square, I know for sure, right? Same thing. And I'm sure you talked about completing the square, I didn't talk to her about it. I know Miss Williams talked about completing the square. So it's just the same thing.
I did too, cause she wasn't here.
No, she was here for that.
She was here for
So
like
this is
a
gonna come out to be 3 root 3 I.
couple- Oh, it's not back with the bed.
Do what?
It was Paul, I didn't even get the Paul, I twisted my.
And so I would even just leave it as -4 plus or minus 3 root 3 I equals x. I just went ahead and rewrote the square root of -27 as this. So notice I didn't show that stuff. Do you have a question about that, Kelly? Do you go with it?
Hold up,
Do you have a question about something then?
I need to catch up on this information.
Oh.
So notice I just rewrote the square root of -27 by simplifying.
This way. What's being subtracted on this side?
Say again.
What's being subtracted on this side? You see negative, not negative, -4?
So I subtracted 4. Whatever I do to one side, I have to do to the other. So it's a -4 plus or minus. Because remember, I want to put my real part first, then my imaginary.
Okay.
Too late.
Okay.
Oh, I apparently forgot.
Why are they having a Halloween party in November? I thought we were supposed to have that. I don't know what she's talking about. What? You don't know what I'm talking about. Been lying.
I'm just going to erase the first of those problems.
I see, you showed.
Once you're done, well, first off, are there any questions that you have?
You gonna put it
What
back
are your
on?
questions I should read? That?
Oh, okay.
Remember, update your knowledge, ask those questions. I know, who was it who asked me earlier to come by and look, see what you did wrong? Okay. So I'll look at that. Put your demonstrate understanding checks together, the ones you just did notes on, I will come and collect them. While that is happening, I know it's a lot of pages, and I will tell you this, we're not going to do all those pages. I'll tell you at times which pages to throw out, because I've worked really hard over the last 3 semesters, to develop a Desmos activity. I'm actually really proud of it because I created this Desmos activity that's going to tackle a lot of the textbook pages without having to go through all the textbook pages. So I'll show you that as we do it. But this is what we're moving into. It's composing and decomposing functions. It's to help us go deeper into the polynomials beyond the quadratics, which we've talked about that a little bit. What would come after a quadratic or x squared? Say again? Cubic or x to the third, x cubed, right? It was going to come after x cubed? X to the fourth. And after x to the fourth? X to the fifth, right? So that's really all we're talking about, but we're going to learn and understand these a little bit better through what are called transformations. While I am making scans of what we have and passing out a few more papers like the next set of proficiency scales, I need one person per group to go grab textbooks. Now, one of the notes I want to make about that, pause 1 second, or continue moving even though I said pause 1 second. I know that we have torn out of these. Go ahead and tear out of these again because these are the ones that my third and fourth blocks still need to tear pages out for solving quadratics. So, take from here and then put them back afterwards, okay? So, take them from there and put them back in that spot. So, yes, Malia? Oh, thank you. And then, so, again, remember, the vast majority of this is going to be taken care of a Desmos activity that we're about to start. So you're going to be able to toss some of these pages so it's not filling up your notebook at times. but I want you to be able to see where we're seeing these things in the Desmos activity. If you look at your proficiency scales, one thing that I started doing last year that I forgot to update is I actually started to note where you can see some of these concepts. So like, I can determine if a polynomial in standard form and in factored form are equivalent. We should already know how to do that, but it does specifically show up in lesson 4 this time. So if you want to hold on to those pages, you can do that as well. Any of this foundation look familiar? I guess better. Does this foundation look familiar, guys? Does any of it not look familiar? Have we seen zeros, zero product property, factors, the whole nine there? Yeah. So this foundation, hopefully, we can check all of it off. Hopefully. Target here. So notice what we're going to try to start doing, we've sketched linear functions, we've sketched quadratics. Now we're going to go beyond that and get into what? Well, we're going to continue with quadratics and go into cubics based on the what? It's on your page. Make sure you're looking at the right side, by the way. It should be the side that says sketching. Sorry. It's on the back side. We're looking at the sketching side right now. So we're trying to sketch polynomials, so quadratics and cubics. Please notice what form is this almost entire unit focused on? Which form? Look through the target section here. We are focused on the, that's a function, not a form. That's not a form. Not a form. Say it louder. We're looking a whole lot at the factored form. We're going to study how the factors create the polynomial units. And so that's what we're going to be getting into even today. And then, please go ahead and do this. I forgot. On the other side about defining and analyzing polynomials, we're not getting to this today, but I forgot these terms. Hopefully we remember that term domain and range. We're going to review it some and practice with it some, but that is a foundation. So make sure you add domain and range to that vocabulary. And on the target side, add the word multiplicity. Remember, foundation is usually stuff that we've talked about in the past or from previous courses. The target is what we're going to get into. But Miles was already showing a little bit. Domain is the X values. The range is the Y values. So we're going to get into more of that soon. Light. You can see it right here, right, Davey? All right. So here's what we're going to get into at this point. We're going to actually start using the Desmos activity to help us start learning about these different functions. Probably just going to start to get in at this point. Malia, why don't you jump in with the tens? Or actually, tens, why don't you go over to the queen side so that we have a little bit more space in a second. But we're going to work together. And so here is the Desmos code. Anyone know how many devices we need per group? One, right? Do y'all know why I want you to only use one?
So we could all work together.
Yeah, if you each had your own device, you would probably just do it all on your device. What do I want you to do? Work together. What's that? There's a C word for that. Collaborate. I want you to think. I want you to communicate. So one person per group. Go to Desmos. Type in that code. I will make this note. Hey guys, don't forget, if you want to write down this code, if you ever log into this, you can always access it again later. And so you can actually use this to help you study. So that's something to consider there. Oh, that also brings up another note. If you struggled with this demonstrator understanding, does anyone know where you could have gone to get some practice before your midterm? Someone said it. Mathia, right? There is some Desmos in there, but remember the Mathia actually has a whole section just on your imaginary numbers. So I would highly recommend that. Okay? Yes. Oh, yes, definitely. If you actually can wait a second, I have to go make those scans, I can grab you paper. I will do that. Alright. So remember, it's up here too. Okay. So, what I want you to do, were you able to just get in? Because it told me yes ma'am. Say again, Shadisha? Zane, does it make it, did you have to wait on me to accept you before you can see the activity? Or did it just automatically let you? Okay. Alright. So, I want y'all to note, hey guys, so I have a few minutes. I want you to note, right here, just to get started, all I want you to do is, I want you to explain how A and B affect f of x, how C and D affect g of x. Hopefully, we already know this, and it should be a very quick little activity. But play around with those, and I want you to talk and write with your group on the vertical surfaces. How are A and B affecting the function f of x? How are C and D affecting g of x? So, go ahead and get started. Does anybody else need me to let them in? That's Desmos, girl. No. Student.desmos.com. Student.desmos.com. Sir. No, he's never allowed to use the restroom ever again.